All right, so last time we started section 13.3, which is partial derivatives. And just sort of to remind you where we were, the idea of a partial derivative is holding one variable fixed as though it's a constant value and only observing that the other value is the one that changes. So you're only looking at change in sort of one direction. And typically we're looking in 3 dimensions, so we're looking at only x or y being held constant. And so we had done this first order partial derivatives and cleaned up our problem in each of those pieces. And we had done a second one. We can talk about second order partial derivatives as well, and then we're going to do an example on that then next. Okay? So, our directions are going to tell us to compute the indicated partial derivatives. And this is example 3. Our function f of xy, and this equals x cubed minus 4xy squared plus 3y. And on this one, we're going to find the second partial of f with respect to x twice, the second partial of f with respect to y twice, and then the second partial of f with respect to y and x. Notationally, even if you're asked the problem in this notation, you can certainly change it so that you are writing the notation down that this is fxx, this is fyy. You have to be careful, of course, when you do the last one because the notation actually switches. It's a different notation, so we actually would write f of x and then y instead of yx, understanding that this is what actually happens first in that notation. So if you want to use that notation instead, that would work. All right, so which notation do you want to use? Do you want to use the subscript notation or sort of the ratio notation? Subscripts, that's my favorite as well. All right, so in order to do the partial derivatives it's requesting, we actually have to do the first partials first, obviously. So we need to find f sub x and we need to find f sub y. So somebody help me, one person, volunteer, help me with f sub x. Caleb, you got it. All right, what do you have?
Oh, right now? Okay.
Yeah, just tell me what you have. What do you think it's going to be?
Well, it'll be 3x squared minus 8y. No, that's minus 4y squared.
Okay.
Then plus 3. No, 0.
Zeros on that one, yeah.
No, it's wrong. Okay.
That's okay. You got it all together there at the end. Everybody good with that? Okay. Somebody else help me with f sub y. All right, James, what do you have?
You get 8xy.
Can we put a negative on there?
Yes.
Okay, good.
The negative.
Excellent. And then what?
And plus 3.
And then plus 3. So this one actually, when we took derivatives, became cleaner. That doesn't always happen, right? But this one actually did, so that's nice. Now we're ready to do the ones that we were actually requested for us to do. So f sub x, x. So now we're going to come up to this equation, f sub x, and we're going to do it with respect to x a second time. Taylor, what do you get? Do you know? The one that's drawn the arrow to.
6x.
Right. And that's it, isn't it? So that one was very clean. How about Jordan? Can you do f sub y for me? You do, negative 8x. Excellent. And then the last one, f sub x, y. Sally? U negative 8y. Fantastic. Just for fun, real quick, I want to point out, because I mentioned this last time, we're not asked to find this, but let's find f sub yx. What would f sub yx actually be? Brandon? Do you know?
Just the first one, or?
So f sub y means, the first part f sub y means that we're going to use this equation with respect to x.
Okay, right. So it'd just be negative 8y.
Right. And the reason I pointed out is because I mentioned it last time, but I wanted to mention it again, that you'll notice that these two happen to match. It doesn't always happen, but most of the functions we're going to work with, it is going to happen for. So it's not a bad sort of check when you're done to check the other one and see if they happen to be the same. If they don't happen to be the same, it still could be correct. You just need to be sort of aware of the fact that if they don't, you also might have made an error on one or the other. Okay? All right, let's do another one. Same directions. I'm not going to write them again. We're going to do one that's a little bit trickier because it's going to be f of x, y, z. All right? And our function is x e to the 2xy plus xz sine of y plus z. And I'll just write above the ones that we're looking for because I'm a little bit out of space here. We're going to find f sub xx and f sub yy. And then we're going to find one that looks a little bit different. We're going to find f sub y, y, z, z. So notice there's actually three first partials we could find here, right? We could find an f sub x, an f sub y, and an f sub z. But this problem does not require me to do all three of them, does it? I really do not need to find f sub z. It wouldn't hurt me to do so, but I'm not asked to do so. There is a z down here at the end, but it's only after I've done the f sub y portion of the problem. So don't do more than you're actually asked to do. So we're going to start with finding those first partials that we need, which is f sub x and f sub y. Now this one's a little harder because there's a product rule. That's exactly right. Yeah. So maybe the word little wasn't even a good word. Maybe it's a lot harder. I don't know. But it's definitely more difficult than the last one. All right, so we do have a product rule on the first piece. So thinking in terms of a product rule, we would leave, well, I tend to do my product rules this way. I leave the first part alone, and then I take the derivative of the second part. So what is the derivative of e to the 2xy if x is my variable?
2y, e to 2xy.
Okay, so the derivative of the power, in this case the inside function, is 2y. And the derivative of the outside function is the e to the 2xy that's already there. Okay, and then the second portion of the product rule is to take the derivative of the first part, which would just be 1. So all I'm going to get is e to the, you know what, I'll write it in just for fun. 1, and then e to the 2xy. So all of that is the derivative, partial derivative of x e to the 2xy. Now I need the partial derivative with respect to x of xz sine of y plus z. So it's just all that without the x. Everything else besides the little x at the beginning is just numbers now at this point, right? It's just the coefficient, quote unquote. So we just have z sine of y plus z. And there isn't a ton to clean up here, but I am going to write one step of a little bit of a cleanup. So I'm going to write this as 2xy e to the 2xy. And I have plus e to the 2xy. And then the last part, there's really nothing to do except for rewrite. So z sine of y plus z. I encourage you to draw a line through the middle of your z's, or to be very deliberate in how boxy, so to speak, they look. Z's can tend to look a lot like 2's if you're not being careful, being a little bit sloppy. So just be mindful of that. We don't use z all that much, so when it does come around, I know that we're sometimes not sort of aware of how much our z's and our 2's happen to look alike, so be careful with that. All right, let's find f sub y now. I'm going to pause and I want you to have a chance. Write down what you believe f sub y is going to look like, and then I'm going to write down what I believe it's going to look like, and we'll see how close we are, okay? All right, so what I have for f sub y is 2y squared e to the 2xy plus x z cosine of y plus z.
It should be an x squared, not 2y squared.
Oh, sorry, I have x squared on my paper. You're right. Good catch, thank you. 2x squared, yes. Everything else look okay? All right, excellent. So we have the two first partials that we need anyway. I mean, like we said, there's another one. We don't need it. So now we're going to find f sub xx. That was the first one listed. So f sub xx means that we're going to take our simplified f sub x equation and do the same thing again with respect to x. So we need the derivative of 2xy e to the 2xy, which we've sort of already done once before, right? I mean, it's very similar to the one we already did once before. It's a product rule. So being that it's a product rule, the first thing is to rewrite the first piece as is, and then the derivative of the second piece. The derivative of the second piece we already did before. That's 2y e to the 2xy. And then we'll rewrite the second piece and leave the first piece unchanged. So the first piece is the 2xy. The first piece is the 2xy. The derivative of the 2xy is 2y. And then we'll leave the second piece unchanged, which is e to the 2xy. So all I've done so far is the derivative of the piece that I've sort of underlined or boxed here in red. Now we need the derivative of e to the 2xy. So what's the derivative of e to the 2xy? That's right, 2y e to the 2xy, which, lo and behold, combines with something on my screen already, right? It will. Isn't that crazy? All right, and then I need the derivative of z sine of x, or y plus z. That one's 0, isn't it? Finally, something went all the way away. And like we said, we can combine these two together. They have all the same pieces. In fact, they're identical. So I actually, we'll simplify this too. So this is 4xy squared e to the 2xy, and then plus 4y e to the 2xy. And there might be cases at what point we might want to sort of factor things or whatever. It won't actually simplify anything here, but there might be reason for which we would factor things later. We've done that sort of thing before, you know, right? Factoring, setting things equal to 0. Sounds like something we might do at some point, don't you think? Might do it. Just might. Maximums and minimums, you got it. Okay, this is the first one we were actually asked to find. So we've done one of the three pieces we were asked to find. This is the first one. All right, next one is f sub yy. So f sub yy, we'll take our f sub y equation up here and take its derivative. So I need the derivative of 2x squared e to the 2xy, and as sort of ugly as that looks like, it's still not a product, right? It isn't. So it's still not a product rule, I should say. So what will that derivative actually give me?
4x cubed e to the 2x.
Right, it'll be 4x cubed because I'm going to have another 2x gets multiplied. So 4x cubed and then e to the 2xy. Well done. The other part, what am I going to get on that one? Mm-hmm.
X z sine y plus z.
Nice. All right, derivative of cosine's negative sine. The x and the z in the front are just constants, and then we've got the y plus z where y is our variable inside anyway. Everybody good with that? Okay, great. So this is the second one we were asked to find. The next one I think I'm going to need a little bit more space, so I'm going to take it onto the next screen and I'll rewrite the piece that I need. So what we're going to be looking to find here is f sub x, x, no, it was y, wasn't it? Sorry. y, and then z. Which means I need the f sub y equation that I just found in order to be able to work with this from the get-go. So to start with, we'll take this equation right here, and we're going to copy-paste. At least we're going to try. I know. Don't you sometimes have this feeling like I'm writing something and man, it'd be really nice if I could copy-paste this, like in written form. Or hit the undo button because you erased something you shouldn't have erased. Ever happened to you? All right, so before we can actually jump into finding f sub y, z, we need to find something else first, right? F sub y, z. All right, we have to do it one step at a time. So f sub y, z, 1z. All right, so taking a look at this, what happens to the first 4x cubed e to the 2xy? Oh, thank goodness something went away, right? All right, but unfortunately, the second part is a product rule. All right, so I've got negative xz, and then the derivative of sine is cosine. So this is cosine and then of y plus z. Thankfully, it is just y plus z and not a product or something on the middle of that, right, in the inside. And then I need the derivative of the negative xz part, which gives me negative x, I think, right? Yeah, negative x. And then we'll leave the second part unchanged, so sine of y plus z. And that's in a good enough form. We can sort of leave it like that as we continue. And then we're going to do y, z. So the first part, again, is a product. Yes? Okay, so product rule. I'll write the first part unchanged. The derivative of cosine is negative sine. So I'm going to go ahead and take my negative off that I just wrote and write this then as a positive. So this is sine of the y plus z. And then I'm going to take the derivative of the negative xz, which would be negative x. And then we'll rewrite the cosine of y plus z. Now, the second piece of this that I'm going to take the partial of with respect to y is no longer a product, right? So what is the derivative of negative x sine of y plus z? So still negative, and this is negative x cosine of y plus z. And we have two of those. Good observations. There are two of those that match. With sines and cosines, a lot of times things will either match or they'll cancel each other. I mean, if the signs might be different, so those two things happening shouldn't really surprise us, but they're very nice when they happen. And then this is y plus z. And then we have minus 2x cosine of y plus z. And that was the third partial we were asked to find. Sound good? All right.